we're talking about momentum again, and momentum, as you recall, use the symbol P, is equal to mass times velocity. And the way you change momentum is you provide a force, but that force has to be provided over a period of time. And so that gives us a new term, which is called impulse. And impulse is force times time. This is a simple way of doing it. Actually, a better way of doing it is to say that momentum is mass times the change in velocity. That would be the change in momentum. And impulse, the change in impulse, is force times the change in time. We're going to look at two balls which provide an impulse to this block of wood. Now, they look the same, and in fact they are both made of rubber, but they are a different type of rubber. So this one, and they have the same weight. This one, didn't have to catch that, did I? This one bounces. So let's have a look and see what happens. I wonder if, I'm going to let them swing and hit this block. I wonder if the one that sticks will hit it harder than the one which bounces. In fact, if you had a ball hit you in the head, would you like to have one that sticks or one that bounces? Which would hurt the most? Anyway, let's have a look at this. I'm going to take this one, maybe just to make sure we know what we're doing. There we go, that's the bouncy one. So we're going to take the bouncy one and we're going to see if it can knock over this, provide its impulse to this block of wood. And here we go, and it knocks it over. No big surprise. Now we're going to do exactly the same thing with this other ball. Remember, it's a different material, so what it actually does is it absorbs all the energy instead of returning it. And so I'm going to do this, I'm going to take it out the same distance, and it doesn't knock it over. So, why does that happen? I'm going to use just a simple way to explain this. The ball which didn't knock it over, it hit the block of wood. It came in with a momentum of mv, and then of course its momentum changed. Momentum changed, and the change in momentum caused an impulse or a force to be provided to the block of wood. So what happened is it came in there and it stopped. So its velocity changed by v. The other one came in, hit the block of wood and went back. So its velocity, it was going v in this direction, and then it was going v in the other direction. So its velocity changed by twice as much. And so it provided twice the momentum to this, or twice the push. One way of looking at this from a practical point of view is if you're doing some carpentry work and you have a hammer, draw my little hammer here. There's a nice looking hammer and a nail. And I've watched people who are just learning carpentry, and so they take the hammer and they go, boom, boom, push it like that, like they're trying to push the nail in. And a good carpenter, you watch him, he goes boom, boom, boom. The hammer bounces. Because if you allow the hammer to bounce, it has a momentum in and then a momentum out. And it gives twice the push to the nail. So physics can help you do carpentry, believe it or not.